In this video, we're going to have a very tricky integral. This one is a combination of exponential function, so this is e to the power 5x, and a trigonometric function, so sine 4x. Now, according to our mnemonic rule, it's called LIPET, so this is LIPET, and this is log, this is inverse trig. Now, this is P stands for power. Then we have exponential, and then we have trig. Now notice that trigonometric functions will always be last, which means we will always put them in the I column, and we are going to put the exponential in the D column because it comes first in the word LIPET. So we're going to put e to the power 5x in the D column, and in the I column, we're going to put sine 4x. Now, the tabular method also alternates rows. So you can see here that we actually have to do it twice. And I'm going to explain in a second why twice, what is good about twice. Okay, so what you got to do is differentiate the D column and at the same time integrate the I column. Now, derivative of e to any powers is exactly the same. So you're going to get e to the power 5x. But because of the chain rule, you have to also multiply by the derivative of 5x, which is 5. So that 5 is going to go to the front. If you were to integrate this, you're going to actually have to multiply by 1 over 5. But if you differentiate, you multiply by 5. Okay, so we're going to do it one more time. Again, we're going to take the derivative, what we see. So that's e to the 5x. And again, another 5 will jump in the front, and this is going to be 25. Okay, so we got that. Now let's do the I column. Let's take the integral of sine. Okay, so first of all, we have to flip the function. So if this was a sine function, we're going to have a cosine function. So cosine 4x. And here I'm already going to put sine. Okay, but what about the number? Okay, so let's kind of go backwards. If you take the derivative of cosine of 4x, you get a negative sign. Remember, anytime you take the derivative of something that starts with the c, something like cosine or cotangent or cosecant, the answer is negative, okay? And so to compensate for that, you have to flip the sign. So you're going to get a minus. And also, just like I told you, if this was a derivative, you multiply by 4. But if it's integral, you multiply by 1/4. So that's going to be 1/4 over here. Okay, when we do it one more time, another 1/4 will come to the front. So this is actually going to be 1 over 16. But what about the signs? Well, if you were, again, go backwards, if you took the derivative of sine, that's cosine because sine does not have a c in the, right? It doesn't start with the c. So there should be no sign change. So that means that if this was negative, this is going to stay negative, okay? So far, I filled out the table. What do I do next? Well, next I'm going to multiply straight across. So let me just quickly fill this out here. And sine 4x, and here is going to be 5 e to the power 5x. Here is 25. And here we are integrating. Okay, so we got the... Right, once we fill this out, we're going to multiply across, diagonally across. What does that mean? So you take this guy and multiply over here, so like that. Then the next step is to take this guy and multiply it like this. And basically you are done, except you also have to integrate the box. Now, why are we stopping at 2? So I'm going to explain that in a second. So let's just write this down. So when we multiply this, I always put the number in the front, so then never put it in the middle because it looks like subtraction, which you don't want. Okay, so you're going to have cosine 4x, and then minus minus, because this sign matters. Okay, this sign will make it a plus, actually. Plus 5 over 16th, and then e to the 5x sine 4x. Now, what did we achieve actually? Like, what's the point? Because you also have to integrate the box. When I say integrate the box, I mean I'm going to multiply whatever is in the last row, and I still have to integrate that. So you are going to have, when you multiply them, let's look at what you're going to get. If you multiply 25 times 16, that's just 25/16. I don't think you can simplify that. The plus and the minus give you a minus, and then you're going to get e to the 5x sine 4x. Now let's pause and compare the integral of the box with the integral that you had to compute. And if you notice, they're basically the same. Here you have e to the 5x sine 4x, and here you have the same exact thing, except for this number. So what's the point? You started with an integral, and then you wound up with the same exact integral on the other side, which you don't know how to do, because the whole point was to integrate it, right? So here you got negative 5 over 16. But the beauty of this method is just the sheer, like, whoever came up with this is really, really smart. So you have exact same integral on the left hand side and on the right hand side. So what we are going to do is we're going to actually add this part, the box, to both sides. What will happen then? So imagine if I have something like this, and I am going to add, so plus 25/16, and then the same integral, right? So what will happen on the right-hand side? Well, that integral is no longer going to be that because it's going to cancel, right? So this part will cancel with that part. But I'm adding it to the other side. So plus 25/16, and then the same integral, e to the 5x sine 4x. Now let's see what happens. You started with some integral. Okay, you added 25/16 of the same integral. And what does that mean? Well, it's like 1 plus 25/16. It's like x plus 25/16 x. Well, what is that? Well, let's go ahead and compute that. So what is going to be on the other side? So if you would take x plus 25/16 x. So it's like 1 plus 25/16. That's going to give you 41/16. So what you're saying is, on the left-hand side, you're going to have 41/16 of this integral, right? And in order to cancel that, so what we would get is this. So we're going to get 41/16 of that integral, right? And on the right-hand side, we don't have it anymore because we added it to the left-hand side. So on the right-hand side, you are going to have that negative 1/4 e to the 5x cosine 4x, and then plus 5/16 e to the 5x sine. Okay? But what you're trying to do, oops, I don't have any dx, I just have plus c, is get rid of this. And that is going to be it. Like, that's the final answer. How do I get rid of 41 over the 16th? Well, I'm going to multiply by its reciprocal. And the reciprocal is 16 over 41. So this is what's going to happen. And then I'm going to put this whole thing right here. That just goes straight inside. Now, you can distribute if you wanted to, or you don't.